you have to come to get there. So for this one, I'm going to start by writing down, rather oddly, what x is, and hopefully you realise why that is, because this is sometimes not just x, is it? But in this case, x, as it's written in the formula sheet, is actually x, n is a half. So I'm looking at my formula sheet. The first term is always 1, then it's n times x, then it's n times n minus 1 times x squared divided by 1 times 2. And after that, the formula book gets a little bit weird, doesn't it? So I just think of it as a pattern. So the next term will be x, x minus 1, x minus 2, so that would be minus 3 over 2, multiplied by x cubed. And this is 1 times 2, this is 1 times 2 times 3. So I'll give you just a second to sort that one out. So I've got quite a lot of this to do. We will go back and do another one of these where it's not A and B if we have time. But I'm fairly sure that that sort of binomial is unlikely to come up. It's far more likely to be this sort of binomial. So just give you a minute to sort that one out.
What's R from the
So R is the number of terms that you it's which term it is. So this is n minus 1, and the next term will be n minus 1, n minus 2, up to n minus... So no, I'm not really sure I understand what R is there. I just think of it as a number pattern.
And you want to say that the numerator would be n minus 1?
No. So this is 1 times 2.
Yeah.
That's 1 times 2 times 3.
And it's 1 times 2 times 4.
But I'm not sure you ever go that far.
Yeah, I suppose. What about the top term?
So the top is n minus 1, n minus 2, n minus 3. And the power of x is which term it is minus plus 1, minus 1. So the third term is x squared, the fourth term is x cubed.
Oh, yeah.
By the end, you'll be used to it. Right. Take 2, Harry.
Oh.
Or is it the one that you're on? So like,
Three one. That's unlikely. Challenging, ice cream,
Are you sure I can't take you?
balance.
Right. So we're gonna jump straight in. Oh, sorry, we haven't sorted this one out. So we get a half of x. So this is minus a quarter divided by 2. That's minus an eighth. I can remember suddenly realising that if you take a quarter and divide it by 2, you get an eighth, and thinking, oh, that's really easy, and not it being one of those breakthrough moments for me. I forget what age I was, but there you go. Yeah, minus a quarter divided by 2, so that's minus an eighth. And then here I've got, it's all positive, thank goodness. I've got 3/8 divided by 6, so that is 3 over 48, which of course is 1 over 16. But that's not the end of it, is it? That's just where I've chosen to stop. So I put the ... I was told to find the first 4 terms. That's that. So this was the question I emailed you. This blooming gluten-free biscuit's going to kill me. So the first thing is, it's one of the few questions where they actually tell you what technique to use. So they actually say it's a binomial question, which is a good job because it's not obvious, is it? It's not looking like this. It's certainly not looking like that. So what am I going to have to do to make this a question where I need to use the binomial? George, suggest a way I could rewrite this question to make it a bit binomially.
You could use like negative powers to get.
Right. Okay. So go on. Talk. You've got my interest, right? So go on. What shall I write?
Write 1. in brackets 1 plus x and then times 1 minus 2x to the power minus a half.
Brilliant. Yeah. Yeah. Now that's the key, isn't it? That's the key to unlocking this problem. Realising that this is the same as this. To the power of minus a half means 1 over the square root of. So that is the same as that. And this is one of two really common types of applications of the binomial, where you are starting with a fraction which you rewrite using negative powers. The other one uses partial fractions. We've got one of those in just a minute. So what we've got here is something which isn't a binomial multiplied by something which is a binomial. So I need to do some gridding out. I need to multiply this by whatever this is. And of course this, if we use the binomial, will be something that goes on forever. So what we're asked to do, and I punched the air when I saw this, is we need to only go up as far as the x squared term. So go on, Jacob, how many terms does that mean I need here if I'm going to only go up as far as x squared?
3.
3, yeah. So in order to know what to put here for this, I'm going to have to binomial this up. And this is where my little thing I write down here is so important, because now x, the thing that I have to write out according to the formula book, is actually minus 2x. And that means x squared will be not just x squared, and x cubed will be not just x cubed, and n is minus a half. So go on, see if you can write down the first 3 terms. I don't want you to have all the hard work yourself, so I'll do the first term for you. Okay, so you do the second and the third term. See if you can write down what they are.
So you're allergic to gluten?
I am only intolerant, so I'm okay in terms of if I have an accent, but yes. And I'm becoming more intolerant, more and more things have to drop off the list. Great shame. Yeah. As gluten is responsible for most of the taste and texture in food, my life is fairly miserable. Thank goodness for crisps and whiskey, that's all I can say. Both gluten-free.
Oh, cheers, sir. Shook it by the door. Cheers.
I did do that this morning, and then at 8 o'clock, I was like,
In fact,
let's see what's going on.
really? Cheers, man.
No worries.
Evening. Of course, as you probably don't know, whiskey's an alcoholic drink. You're better to enjoy that when you're 18.
So I told you before, this face goes anywhere.
I'm a big fan of brackets when it comes to this.
I can count on one hand how often you put typing works.
Where have you got the minus 3 over 2? So it's, if you look at the formula sheet, the third term is n times n minus 1. So if you take minus a half and take away 1,
Right.
that's
Okay.
minus 3 over 2. And because your calculator will do this for you, provided you get the coefficient of x squared correct, you can just type that in without the x, can't you? If you, you know, I'm trying to do it as much as I can in my head, but there's no need to. So minus half times minus 2 is plus 1, that's all good. This, remember, is 4x squared. Minus 2x times minus 2x is plus 4x, so I've got minus a half times minus 3 over 2, so that's positive 3/4, multiplied by 4, 3, divided by 2. So I reckon that's 3 over 2x squared. But I'm just going to double check that because
That's what I got as well.
it must be right. I won't bother checking. I won't bother checking. But this is where the mistake often happens. When you've got something other than x as your x value, remembering that when you square it, you've got to square the coefficient as well. Right, and of course that's dot, 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 but so that's going to go in here. So if you multiply it out, that will give us the end to the answer to part A. There are some terms we won't need to worry about because we're going to get an x cubed term here, and we're not interested in x cubed terms. So actually, there's not a great deal of work. Well, I say it's not a great deal of work. It's not a huge amount.
So I suppose running around this floor we can fill water.
Maths office. No
Go exactly there, yeah.
Yeah. So go in on the plan. If anyone challenges you, say, do you know who I am? Sorted?
For validity, Satan,
Yeah.
you go to the original. When it's
Absolutely. Absolutely.
I want to
Yes.
say
So
minus
that has to be
2.
between minus 1 and 1. Yeah.
Or 2x and minus 2x.
Well, it doesn't matter, does it? That thing can't be bigger than 1 or minus 1. So tell me what that means about the value of x.
That's the one.
Yes, the negative.
So x is usually minus half, if that's correct.
Yeah.
Sometimes if you use that.
Right, so you should hopefully get that. Can we get that? So we've got a 1, an x, and another x. So that's my 2 x's. I've got 1.5 x squared there and another x squared there. So that's my 2.5, my 5 over 2x squared. So that's good. Now validity is an important, I've given the game away there, really sorry, I should have been a bit more careful. Validity is a really important part of the binomial. We go back to the thing we've expanded, which is this. And we say, right, this only works if this is small, and my definition of small is that that has to be between -1 and 1. So,
Well, why is it that it only works?
because otherwise, the reason we can stop is that because if you substitute a value in, these terms are getting smaller and smaller. If x is a number less than 1, when you square it, you get a number that's even smaller, and when you cube it, you get a number that's even smaller. If x was a number bigger than 1, then this term would be bigger than this, and this would be bigger, and we'd be getting bigger and bigger. The reason we can stop is that the terms are so small that it's making no difference to the total. So what we're basically saying is that x has to be between, in this case, between -1/2 and 1/2. And you've got the option of the modulus statement, which is much beloved of some people. This next bit is really fiddly, and it so often crops up. Sometimes we have to substitute a value of x into our expansion, but that's not what they want us to do now. They want us to do something to the original question. They want us to make x equal to 1/100 and show that it becomes this. So do me a favour, see if you can do that, but can you see if you can stick with fractions? Because you'll end up with a fraction on the top divided by a fraction on the bottom. And I know how to divide fractions. I write down the first fraction, I change the divide into multiplication sign, and I flip the second fraction. So just see if you can do that, leaving it as a fraction. I'm going to leave that answer there because we're going to use that again in a minute. So 1 plus 1/100th is 1 1/100th, which I'm writing like that. And 1 minus 200ths is 9800ths, which I'm writing like that. Now, when I first did this, I did it as decimals and got absolutely nowhere. So you're getting the benefit of me having tried and failed. And here's where we use one of those important surd rules. The square root of 98/100 is the same as the square root of 98 over the square root of 100. And that's good news, isn't it? Because I know what the square root of 100 is. So the square root of 98/100 is the same as the square root of 98 over the square root of 100, and we know what the square root of 100 is. Here we go, we're going to write it as a fraction multiplication sum. Bish bash bosh, stay change flip, however you want it.
You're going to serve the 98 or not?
Sorry?
You're going to serve the 98 or?
You're going to surd it? What do you mean?
As in, you're going to leave it as the square root of 98?
Well, are you about to tell me how I can simplify it?
Oh yeah, you can simplify, yeah.
And you could do that with your calculator, can't you? So what do you get when you surd it up?
7√2s. Series.
Which is great news, isn't it? Because I was hoping to see a root 2, although at the moment it's in the denominator and I want it in the numerator, but I feel okay about that. Okay, so let's multiply it out. Now Isabel, how have they got the square root from the bottom to the top? What's this next process?
Rationalise.
Oh, look at that, she's whipped it out from nowhere, yes. So we've rationalised that fraction. We know that square roots in the denominator are problematic because when we want to add or subtract fractions, we want to be able to manipulate the denominators. Really hard to do. But as it's a fraction, whatever I do to the bottom, I can do to the top. Sorry, that's the square root of 2. And the square root of 2 times the square root of 2 equals 2. Now, you know, okay, then we cancel it and divide by 10. That's horrible, isn't it? That's horrible. And these, I think we've done a few of these. You probably don't remember them, I do. And it's just, like I say, I got it on my second or third attempt. If we had more time, I would have said, go away and struggle with it. So what we've shown is that this can roughly be written as this. That's what the binomial expansion is doing. It's giving us a different way of writing something. So when I make x equal 100th, this is roughly that. And they say, right, okay, so substitute 0.01 into that and tell me what root 2 is. So I hope you can see how we would go with that, how we would go from what we get when we substitute x is 0.01 into that, which we've just shown is that, to what root 2 is roughly. Go on, have a go. So this is our answer to part A. And it's interesting, only 3 terms in the expansion, so we usually see how accurate this answer is.
Is it not 5 over 2x squared?
It was, wasn't it? Thank you. And it was 2x, wasn't it? Yeah. Sorry. Again. I always now do 0.01 arrow x and then just type that in. So that is roughly that, and we're asked to use that to work out what root 2 is, so hopefully you just multiply by 140 and divide by 101. Five decimal places. Which I think is quite amazing, is correct to 5 decimal places. If you actually work out the square root of 2, that is correct. So we got that by just using a binomial expansion with just 3 terms in it. There was an awful lot of jiggery-pokery in between. Number of marks. C's really nasty, isn't it? But it's only 2 marks, and it's one of those questions that if you don't get it, you can still go on and access the last bit. So it seems to me that, you know, I'm not going to worry so much about that. I can get 8 of the 10 marks without having to do that bit. And it may be that I can pick up one of those marks, even if I don't get anywhere. But yeah, 4 marks for the binomial expansion. That's the hard work, isn't it? And of course, if you didn't spot the original trick that George pointed out to us, then we had a problem. Always be a validity questions. That's a nice, easy 1 mark. And this seems like quite a nice, easy 3 marks. I mean, nothing's easy at A level, but that just seems to me to be, you know, quite a nice finish. There, I don't know if I've scared the whatevers out of you by doing such a hard question, but you know, that's a 10 marker, so that's a big question, isn't it? But the binomial expansion is the key thing there. It unlocks it, and that's one of the first of 2 ways I think we're going to see the binomial expansion. I don't know, but I'm just trying to predict.
What was our answer to D?
So our answer to D, when I made x equal to 0.01, I got that.
Yeah.
So that is 101 root 2 divided by 140. So if I want to know what root 2 is, I just multiply by 140 and divide by 101, which gave me 1.4141. And when I work out the actual square root of 2, I get the same answer as far as 5 decimal places go.
So is that error carrying forward on those questions as well?
Well, that's a really interesting question. I've got the mark scheme here. Actually, it's not a proper mark scheme, this one.
Like if you get the binomial.
Yeah, I guess, yeah, I guess you probably would, wouldn't it? So if you had your expansion wrong, but you correctly substituted into your wrong expansion, yeah, I would have thought there would be maybe not all 3 marks, but there would definitely be marks up for grabs there. But let's not make the mistakes in the first place. Okay, before we go to the second sort of problem, we need to address one big thing about binomial. Binomial, we've already said, and this is year 2 binomial, only works when this is small. N can be anything, but this has to be 1. And in this case, we don't have 1. So I just need to remind you how we deal with that before we go any further. So let's start by writing this as a power. It's not 1 over this time, it's just to the power of a half. That's nice and easy. Again, they are being nice and telling us to use the binomial expansion. 4 terms this time. But I mustn't leap in because I don't have a 1. So what I need to do is factorise to turn it into a 1. And in order to do that, I have to pull a 4 out. But of course, it's not a 4, is it? This is something to the power of a half. So when I pull that 4 out, and this is absolutely crucial, James, you've got to pull out 4 to the power of a half, which is 2, the square root of 2. So when you factorise to turn that into a 1, it's got to be the number to whatever that power is. So if it was to the power of -1, I'd be pulling out 4 to the power of -1, a quarter. However, I've divided that by 4, I've got to divide that by 4 as well. So what I've got is my x is -9/4 of x. N is a half, and we want 4 terms in the binomial expansion. Go on, see if you can do it. Then, when we get the answer, we're just going to double everything. So we're going to forget the 2 for a moment and do it as if the 2 isn't there, but at the end, we'll double everything. wonder if this is a strategy that might help, actually writing out what x and x squared and x cubed are. So that would be so if you wrote that out ahead of actually substituting it in, that might, I don't know if that might help. Just check I have cubed.
X cubed would be minus.
It would be, thank you. He's all right at the moment. Oh, you're assuming you're going to be offered again, are you? For a presumption.
No, thank you.
Oh my god.
It's a lot easier to do that bit first, because then I can just multiply the fractions together.
No, I said I didn't swear off. Yeah, no, I swear off that. Good enough. One. Your normal work is like this house, it's I think that's just a
I'm cheating now. So my answer to this expansion is this, all negative this time. 1 minus 9/8 of x minus 81 over 128x squared minus 729 over 1024 x cubed. But of course the answer to this will be double all of that because we pulled out the 4 to the half. So it's 2 plus 9/4 of x minus 81 over 64x squared minus 729 over 512 x cubed. And that's the final answer. Is that correct? Yes. Right, so you could just get a question like that. It might be early paper, 4 or 5 marks maybe. But the reason I've done that, of course, short of time, is because I think this is the sort of question that is very likely to come up. Now actually, this is the question as presented to you. So the first part of the question was a partial fraction question, and I thought, well, we won't have time to do partial fractions, so I'm hoping that you'll be able to do the partial fraction bit. And actually what we end up with is b is 0. So I've done part A for you. So what we've now got is part B. And part B doesn't mention binomial. Instead it talks about a series expansion. Well, there are a number of ways we could do this binomial thing. There are a number of different approaches we could use, but the binomial is an example of a series expansion, and it's the only one we've got at A-level maths. It's the only one we've got. So this is a binomial question as well. And of course the wording, ascending powers of x up to and including x cubed, that sort of gives us another hint, doesn't it? So what we've got to do is we've got to somehow turn this into a binomial problem. That's disappeared, that term has disappeared. So this brings us back to what George suggested at the beginning. So go on, Harry, how could I rewrite this term a bit like the way that George rewrote that first question? So do you remember what the first one, we wrote it as 1 plus x times 1 plus 2x to the power of minus a half? Brilliant. So that. Brilliant, yeah. And I can binomial that and then just multiply it by 3. And then the next term here, which I'm going to write here, but it's added to that, would be 4 lots of so I've got to do it, and of course the problem is it is one of these, isn't it? It is one of these. So let's deal with that first before we do any binomial expansion stuff. So I've got to pull a 2 out of the bracket, but Pat, what's it actually going to be I pull out?
2 to the power of minus 2.
2 to the power of minus 2. Now 2 to the power of 2 is 4, so that's a quarter, isn't it? So what I've actually got is 4, that 4's there all along, times 2 to the power of minus 2. Both things in the bracket divided by 2. But that equals 1, because that's a quarter. 4 times a quarter is 1. So actually I just end up with that. So I've got 2 separate binomial expansions to do. So why don't, as we haven't got much time, if you're on this side of the room, why don't you do that one? And if you're on this side of the room, why don't you do that one? If you're on this side of the room, you haven't got to do anything to your final answer because we're multiplying it by 1. If you're on that side of the room, now you've got to multiply your final answer by 3. Okay? Have a go. Have a go. So be clear on why that's suddenly become a 1. It's because we've pulled out 2 to the power of minus 2. Are you okay? Have I made a mistake?
No.
It often happens. So I've done your x squared and x cubed for you for both sides.
Do you mind saying what?
Yeah. I did. But then you have to divide that. Well, how
Do
about
27 times by 6, and then, no, 27, yeah, 27 times by 6, and then divide it by 6.
Yeah, and then times by 3
Oh, yeah.
at the end.
Oh, yeah.
You give me.
But it's plus, isn't it?
I got minus.
Minus 1 is minus 2, minus 3 is minus 6.
Yeah.
That's minus 27 is plus.
Why times 1 minus 27?
Because minus 3 cubed is minus 27x cubed.
Okay, that's better.
Often you can cancel out top and bottom, so that's going to be
Why is it to the power of 4?
Sorry?
Why is it to the power of 4?
Where have I done to the power
Where
of 4?
you've just wrote 3x to the power of 4 at the bottom.
Oh, sorry.
Okay.
Thank you. So that is going to be minus 4 over 8. So I get that, which I've got to multiply by 3. So that's 3 plus 9x plus 27x squared plus 81x cubed. That's that. And then I've got this, which I don't need to multiply by anything. So we've got the mark scheme here. Let's see if we're...
Is it that? Is it? Are they
So
added?
those two are, let's just double check, are they added? They are added, aren't they? So we've got to add those two together, right? So, what's the answer now? Do we end up with 4? Yes, we do. Do we end up with 8x? Yes, we do. Do we end up with 27 3/4 x squared? Yes, we do. And do we end up with 80.5 x cubes? Yes, we do. So there we go. So we've looked at basic binomial expansions. We haven't had time to go on to back to some of the A plus B practice, so it might be worth finding some practice of that yourself. But certainly being aware of that sort of problem and that sort of problem, I think is really, really key. Both of those questions I got from a linked PDF. So there are 2 sets of resources, aren't there? There are the folder of resources and the linked PDF. I found the folder resources was a bit tricky. It went in quite hard, quite early, whereas these are hard enough. I find binomial really hard. So maybe the linked PDF would be a good place to look. It's on paper 2, binomial, pure paper 2. So that's so the linked PDF. Oh, I see.
Before you get better at that.
He's having a little joke. Take care, James. Please help yourself to another biscuit as you leave. You're very welcome.
Hilarious.
I like that.